January 2005, and Asia struggles to clear up after the 2004 tsunami and come to terms with the appalling destruction that claimed the lives of over 250,000 men, women, and children. Tragically, this was not a one-off event. These catastrophes have happened before and will certainly happen again. 122 years ago, another natural disaster struck in the same geologically active region of Indonesia. This disaster was not caused by an undersea earthquake of the kind that created December's tsunami, but by the volcano Krakatoa. This film is the story of that eruption, but it is also an account of the first tentative steps towards understanding the terrible power of Earth's natural forces. On the 27th of August, 1883, the uninhabited volcanic island of Krakatoa blew itself out of existence with an explosion the equivalent power of 150 million tons of TNT. The eruption was so loud, the sound was heard over a twelfth of the Earth's surface. The shock waves reverberated around the entire planet 7 times.
These vibrations are airborne. It's not coming through the ground. It's not an earthquake.
This explosion also caused giant tsunami, the largest of them twice the height of those of 2004.
God. Turn them into the wave now!
These enormous waves wiped out 165 Indonesian towns and villages, killing over 36,000 people. Within hours, news of the disaster was transmitted around the globe, and scientists of the time struggled to comprehend the geological forces that caused the tragedy. This film reconstructs the true stories of survivors, from their accounts and diaries, to piece together what happened in the months leading up to the most famous eruption of all time. The eruption of Krakatoa, over 120 years ago, has become a landmark in our understanding of how volcanoes affect our planet. Mike Rampino is professor of geology at New York University. His research has been instrumental in discovering why Krakatoa erupted with such force. He's returning to Indonesia for the first time in 26 years.
The 1883 eruption of Krakatoa is one of the most important eruptions in the history of science. I think probably the most important eruption in terms of history of volcanology. For the first time, a large explosive volcanic eruption took place when there were enough observers spread around the world, on land, on ships at sea, to really get a global synoptic picture of what happens when a large volcanic eruption takes place.
Krakatoa's devastation was not wreaked by the eruption itself, but like the disaster of 2004, the massive death toll was caused by tsunami. Volcanologist and writer Bill Maguire from University College London is an expert in tsunami, but those generated by Krakatoa in 1883 are of particular interest to him.
No tsunami on the scale of Krakatoa are known. I mean, these waves were really quite extraordinary. I mean, a wall of water, 120, 130 feet high, 40 meters high. At the time, nobody would have understood that a volcano, which is the closest 25 to 30 miles to Java, would have posed any problems at all. I don't think anybody thought it was going to come and get them, because they didn't know about tsunami, certainly as a result of a volcanic eruption.
Indonesia is a group of thousands of islands in Southeast Asia. Two of the largest islands in this archipelago are Java and Sumatra. Separating them is a busy waterway known as the Sunda Strait. The volcano Krakatoa lies in the middle of this stretch of water. Today, only a remnant can be seen of the 1883 volcano. To understand what Krakatoa was like in 1883, Mike Rampino has traveled to the volcanic national park of Tengah Bromo in East Java. Indonesia is the most volcanically active region on the planet. The country contains 17% of the world's active volcanoes. The view at dawn from Mount Penanjakan shows several of these volcanoes within a few miles of each other. This is the jewel of Indonesia, but it's a beauty born from brute force.
There's a kind of rule in geology that the more beautiful the landscape, the more dynamic the processes are that create those landscapes. And volcanism is one of the most dynamic processes that exists on the planet. And so we see these beautiful volcanoes, these craters with steam and ash coming out, and we think how beautiful, how dramatic, how gorgeous. But it's what's underlying this, what's going on underneath the ground, inside the earth, that makes this such a dangerous situation.
Indonesia has so many volcanoes and earthquakes because of its geographical position. The archipelago that starts in northern Sumatra stretches over 3,000 miles south. It has been created by the forces where two of the tectonic plates that make up the Earth's surface meet. The ocean floor of the Indo-Australian plate and the Asian landmass of the Burmese continental plate are in collision. As they push against each other, the heavier ocean floor is forced underneath the lighter continental rock.
When these plates or slabs come together, one pushes its way down back into the interior of the Earth. That process is called subduction. And as that crust is pushed down into the hot interior of the Earth, the rock melts. And some of that melted rock finds its way back up to the surface through fissures and cracks, and erupts at the surface to form volcanic eruptions.
Krakatoa lies directly above this subduction zone. volcanologists have pieced together Krakatoa's eruptive history. In 416 AD, an ancient Krakatoa destroyed itself in a massive explosion. Over the next 1,200 years, regular minor eruptions rebuilt the volcano. These small eruptions helped release the pressure created by the enormous geological forces beneath the island. But over time, a plug of thick, viscous magma formed in Krakatoa's throat, preventing the gases and magma from escaping to the surface. The eruptions ceased, and by 1883, Krakatoa was a time bomb, waiting to explode. Within sight of Krakatoa were the low-lying and densely populated coastlines of West Java and southern Sumatra. Situated at the southern tip of Sumatra was Ketimbang, just 23 miles north of Krakatoa. In 1883, Ketimbang was a rural outpost of the Dutch colonial empire. For over 250 years, colonial rule in Indonesia had effectively reduced the locals to tenants in their own land. But an uneasy peace existed, and there seemed little that would disturb the daily life of this heavily populated coastal village. The controller of Ketimbang was Willem Berink. As a Dutch official, he was responsible for enforcing colonial law and order. Each morning, he would hold a clinic for the administration of the affairs of the local people. Berink was well versed in a number of skills, including Islamic law, local languages, and rudimentary geology. With the local Indonesian population serving as an extensive workforce, Mrs. Berink ran a large colonial household with numerous staff.
His name is Yanni.
Krakatoa had been dormant for over 200 years, but forces deep beneath the Earth's surface were about to wake this sleeping volcano. By March 1883, subtle warning signs of the danger that lurked below the volcano were felt on the surface as faint tremors, undetectable to human senses.
What's the matter with you, eh? What is it? Get yourself set about, eh? Shh. There now.
Near Ketimbang lived fisherman and village elder Ajib. Ajib was one of the local spiritual leaders who acted as guardian to traditional Indonesian beliefs passed from generation to generation. Although regarded as pure superstition by the Dutch, the local belief was that the volcano Krakatoa was home to the fearsome fire-breathing god Orang Alijay. When Krakatoa had erupted in the past, it was because Orang Alijay was angry, and Ajib was convinced that one day soon the volcano would erupt again. Across the Sunda Strait on the west coast of Java, a series of lighthouses had been erected to help navigate the waters. The closest to Krakatoa was Fourth Point Lighthouse at Anya. As its recently appointed keeper, Temang would be one of the first to witness the beginning of the eruption. He was married with a son. Passing even closer to Krakatoa was the Dutch government steamer, the Governor-General Loudon, that regularly crossed the Sunda Strait. The ship was under the command of Captain T.H. Lindemann. The captain and crew of the Loudon would be the witnesses closest to Krakatoa's eruption. "83 miles east of Krakatoa on the north coast of Java is the port of Jakarta. Today, Jakarta is a busy hub for shipping in the Far East. But in 1883, the city was the capital of the Dutch East Indies. Holland had been a dominant force in the commerce of the spice routes. Oriental spices and raw materials were highly prized, and in the name of profit, the Dutch ruthlessly exploited Indonesia, exporting everything from gold, rubber, and sugar to cinnamon, pepper, and timber. Large numbers of trading ships would travel back and forth to Europe. Each one would dock in Jakarta, or Batavia, as it was then known. In 1883, Dr. van der Stok was the director of the Magnetic and Meteorological Observatory in Batavia. He was responsible for monitoring seismic activity throughout Indonesia, and his observations of the early stages of Krakatoa's eruption would help modern volcanologists understand why the volcano exploded with such force. Also stationed in Batavia was J. Sherman, an energetic young geologist with a basic understanding of volcanology. Sherman's expedition to Krakatoa would provide a first-hand account of the erupting volcano, as well as valuable samples of pumice.
Sherman,
Director?
have you come to return my books?
Oh, I've not quite finished with them yet.
You know the 11th commandment?
I find 10 hard enough.
All books borrowed must be returned on pain of hellfire.
Is God a librarian?
Well, if he was, you'd be struck down dead where you stand.
I was wondering if you had anything on animal behavior. You know, there's an old Japanese story about catfish. They behave oddly just prior to an earthquake.
Really?
Well, you've seen for yourself how dogs and domestic animals become disorientated just before a thunderstorm.
I don't believe I have anything on the subject.
That only goes to show there's a book to be written on it. Just think, animal behavior could be used to predict the weather, even earthquakes. I've heard that the Chinese use grasshoppers. If we could relate the results of your instruments with observed changes in animal behavior,
Sherman,
then...
enough. This is hardly science.
Of course this is science. Everything's science.
In the 1800s, science and technology were marching mankind into the modern era, and the public's curiosity about the natural world was at an all-time high.
The Victorian age is a great age of discovery and observation, and everyone was keen on recording things, natural phenomena. So barometers existed in gentlemen's clubs here, there and everywhere. People were very interested in the weather in particular. And so these different measuring devices started to crop up all over the world, and that was fortuitous because it meant when the eruption actually happened, not only could the events be recorded in Indonesia itself, but the distant effects could be recorded right across the planet.
Well, that all seems in order. Thank you. Pergi. Anna.
I thought we might take a walk this afternoon.
I'm rather busy.
I know. But I can hardly wait until you're not busy, can I? Then I would wait forever.
Well, perhaps tomorrow, Oh, no, I can't. I have a report to write. I have to get it off to Batavia tomorrow.
And if your report is one day late, will it matter?
Why can't you accept that I have a job to do?
As controller of Ketimbang, one of Bering's responsibilities was to report large tremors to his superiors in Batavia. But having no clue where the tremor had come from or what had caused it, he was unaware of the danger that lay only 23 miles out to sea. Just before midnight on the 9th of May, 1883, intense pressure building deep beneath the Earth's crust broke through the line of weakness directly below Krakatoa. Magma, moving towards the surface, split the crust apart, creating a large tremor. What the lighthouse keeper witnessed is now recognized as the first documented warning sign of the beginning of Krakatoa's 1883 eruption.
In May 1883, the lighthouse keeper here at the 4th Point Lighthouse actually saw the sea sort of go flat calm just for an instant, and he would have thought this was rather strange. Now what he was seeing then was the result of fresh magma actually breaking rock on its way from deep down within the crust to the surface. When that happens, when the rock breaks, it generates earthquakes, and as those earthquake waves travel through the sea, they cause it to freeze, if you like. It's the same thing that you see when depth charges explode beneath the surface. And so that's what he would have seen. He would have seen the normal behavior of the waves, then they would have frozen for an instant, and then they would have carried on again, and that would have been obviously rather odd to him.
To momentarily freeze the waters of the Sunda Strait required incomprehensible geological forces. After 200 years of dormancy, Krakatoa was about to wake from its slumber. In the early 1800s, the volcanic island of Krakatoa had been used by the Dutch as a penal colony. The island had also served as an outpost for naval reconnaissance. But by 1883, Krakatoa was uninhabited and only frequented by fishermen who used the surrounding waters as a rich hunting ground. and the fertile jungle for timber to build their boats. But all that was about to change. Days after the tremor at the lighthouse, in the early morning of the 20th of May, the tranquil island of Krakatoa burst into life. Intense pressure building beneath the most northern crater was finally released.
What's happening?
There, Captain.
Dear God. Hold this course as best you can.
The initial eruption was witnessed by people aboard a dozen ships in the Sunda Strait, including Captain Lindemann on the Governor-General Ludon. Moments after the eruption, shock waves were felt 23 miles north in Ketimbang. Minutes later, the blast was felt 83 miles away in Batavia. The shock wave was registered in Dr. van der Stok's observatory. Among his many instruments was a magnetic declinometer fitted with floating needles that were so sensitive they detected the tiniest movements through the ground or through the air. Using the readout from the declinometer, Dr. van der Stok deduced he was dealing with an air blast caused by an explosion nearly 100 miles away.
Did you register a tremor? Does that correlate with your instruments?
It's not an earthquake. Take a look at this. Needle has been moving in a vertical plane. These vibrations are airborne. It's not coming through the ground. It's not an earthquake.
Then volcanic.
I think so.
At last. I've always wanted a volcano. What do we have on the subject?
But even van der Stok could not have predicted the scale of devastation Krakatoa would wreak. Because he witnessed the eruption firsthand, Captain Lindemann's log now forms a vital part of a body of information about the eruption.
On the 20th of May at 10:30 in the morning, a volcanic eruption was observed on the island of Krakatoa. We saw from the island a white cumulus cloud rising fast. It rose almost vertically until after about half an hour it had reached 11,000 meters. Here it started to spread like an umbrella as it had reached the height of the westerly winds. Soon, only a small part of blue sky was seen on the horizon.
This initial eruption, however, was only the prelude to a far greater explosion yet to come. Krakatoa had finally woken from its slumber. Volcanologist Mike Rampino is crossing the Sea of Sand, a vast volcanic plain, on his way to one of the most active volcanoes in Indonesia. Mount Bromo has many similarities to Krakatoa. It is fueled by magma generated from the friction of the Indonesian subduction zone, and its crater is approximately the same size as Krakatoa's. But Bromo continuously releases the pressure beneath it and is known to have erupted 50 times in the last 200 years, and so never on the scale of Krakatoa in 1883.
The initial eruption of Krakatoa on May 20th, 1883 was typical for the beginning of an explosive volcanic eruption. There was a sudden explosion and a rise of a column of ash and steam and gas, in this case very rapidly up to a height of about 30,000 feet above sea level. What had happened is a viscous plug of congealed magma and rock was sitting in the throat of that volcano for 200 years. And finally, the pressure below it built up to the point where the rock cap broke. That released the pressure on the magma chamber inside the volcano, and that's like popping the cork on a champagne bottle. And in fact, it's like shaking up the champagne bottle first and then popping the cork. This violent eruption was the opening salvo for a series of eruptions that were to take place over the next few months.
As eyewitness reports of the eruption flooded into Batavia, the authorities ordered Willem Beering, as the closest official to the volcano, to go to Krakatoa and report on the scale of the volcanic explosion. The following morning, Beering and the local fisherman Ajib began their journey to the island of Krakatoa. The volcano that normally dominated the horizon was now invisible, shrouded in clouds of acrid sulfurous gas. Their progress was painfully slow.
Stop, stop. Turn around! Panic! Panic! Panic time!
Although Beering had only ventured within sight of Krakatoa, it was clear to him that the volcano was now a serious threat. On his return, a concerned Beering wired a report of the eruption to Dr. van der Stok at the Magnetic and Meteorological Observatory in Batavia. The Governor-General was immediately informed. By the 27th of May, 1883, the large eruptions on Krakatoa had abated. During this relative lull in activity, an eerie calm now shrouded the mountain. Driven by scientific curiosity, Schumann and van der Stok set foot on Krakatoa to investigate. As they began their ascent up the slopes of the active crater, they saw that large areas of the once forested island now lay charred and smoldering.
Have done this. These trees have been completely flattened by some immense force.
The entire forest has been stripped bare. What do you make of it?
Well, It's as if some superheated whirlwind has torn down the mountain. It's remarkable.
Indeed.
Sherman's report to the authorities now provides invaluable evidence of the devastation on the island.
Following in the footsteps of the bravest, or perhaps the most foolhardy, we climbed the bare hills, which did not offer any obstacles other than the loose ash. Horrible was the view of that somber and empty landscape, which portrayed itself as a picture of total destruction. Foul-smelling smoke permeated the landscape, causing us to gag. In addition to the smoke, one also recognized amongst the gaseous products sulfuric acid, which made itself known by its smell.
The samples collected by the expedition are now a vital record of the volcanic material ejected by Krakatoa in the early stages of eruption.
I expect this is what hell looks like. Should be getting back.
I want to see the crater!
We don't have the time.
I'm going up there!
Sherman, no.
You've become too comfortable stuck in your observatory. Come on! Come! Come on!
Not too far now, Doctor.
Not too far. Soon every sign of vegetation disappeared, and all we could see was the roaring column of smoke. We climbed the last hill, and we were standing at the steep edge of the crater wall.
Who thought hell could be so beautiful? You really are quite mad, Sherman, aren't you?
Sherman and van der Stock believed that the worst of the eruption was over. Little did they know that in 3 months' time, the entire island of Krakatoa would have blown itself out of existence. Volcanologist Mike Rampino is at the lip of the crater of Mount Bromo in East Java. Bromo's crater is a similar size to the one Sherman would have seen on Krakatoa.
Sherman, in a sense, was one of the first volcanologists. At that time, volcanology was in its infancy, and we didn't know much about the behavior of volcanoes. And in fact, the study of Krakatoa was the first real study of a volcano that began to give us information about how volcanoes work. And Sherman actually did a very valuable thing. by collecting samples of the material that had been erupted by the volcano during its earliest stages of eruption. Clearly, when Sherman walked across Krakatoa, he should have known that it was a dangerous place to be.
Sherman's party had no real understanding of just how dangerous their expedition had been. Today, volcanologists like Mike Rampino fully understand the deadly forces that had stripped the slopes of Krakatoa, forces known as pyroclastic flows.
They were quite lucky to be there during a time when the volcano was less active, because the area had been devastated by pyroclastic flows and surges, hot mixtures of ash and gas.
Krakatoa's first eruption had thrown fine particles of ash high into the atmosphere, but the real danger lay closer to its flanks. Heavier material had cascaded down the sides of the volcano as superheated debris. Anything standing in the way of this pyroclastic flow would have been incinerated instantly. By the end of May 1883, Krakatoa, the volcano that had violently awoken after 200 years, returned to relative calm. For 3 months after Sherman's expedition, all that was noticed on the island was a continuous plume of smoke and the occasional rumble. Because of the widespread belief that the eruption was over, life in the coastal communities of West Java and southern Sumatra returned to normal.
It's fairly common during many explosive eruptions, during the early stages, that you get some activity and then things quieten down again. This is the really dangerous thing about explosive eruptions. It's almost impossible to predict when the climax is going to be. In the case of some eruptions, it can come within a week. In the case of Krakatoa, it came months after activity started. And there's a danger always that once activity has died down, people are going to say, well, that's it, let's forget about it, we're all safe now. But that often isn't the case.
Along the coastlines of West Java and southern Sumatra, the morning of Sunday, the 26th of August, 1883, was as any other. At 6 minutes past 1 on the afternoon of Sunday, the 26th of August, 1883, all 3 craters on the volcanic island of Krakatoa erupted in a massive volley of explosions. The enormous pressure that had been building for hundreds of years was suddenly released. What was to become the most devastating volcanic event in recorded history had begun. The densely populated communities living within sight of Krakatoa, on the coastal areas of West Java and southern Sumatra, now had only hours before the full force of the volcano would devastate the area.
Once the volcano really started getting going at lunchtime on the 26th, things were going to go from bad to worse. There were big explosions every 10 minutes or so, and these merged together to form a column of ash and debris which extended up to something like 25 kilometers, 18 miles into the atmosphere. There was heavy ashfall, there was a lot of pumice falling on ships out in the straits, and by late afternoon everywhere was pitch black, and you probably could hardly see a hand in front of your face. You would have had earthquakes going on accompanying these explosions. At the same time, you would have been having these flows of hot debris called pyroclastic flows entering the sea, and the sea would have been getting increasingly agitated.
The ship closest to Krakatoa that afternoon, just 12 miles away, was the Governor-General Ludon.
Keep her away from the coast! We mustn't be drawn inland.
Hot, sticky volcanic ash fell from the dark clouds, smothering the ship.
Get that paraffin off the deck before it explodes! Overboard! All of this! Overboard! Overboard!
The heavy rain of ash and pumice spread 23 miles north to Ketimbang in southern Sumatra.
They would have experienced ash starting to drift down, and then maybe sort of pellet-sized bits of pumice and bigger bits of pumice falling, and generally just this increase in the amount of material falling out of the sky. When it got really dark, when the ashfall was so heavy that you couldn't really see anywhere, then I think temperatures would probably have risen, because beneath very heavy ashfall, it does get very sticky and muggy, and it's not hot, but it is warm, and they would have experienced that.
At 5:30 the following morning, the first of 4 truly cataclysmic explosions occurred on Krakatoa. The volcano erupted, literally ripping itself apart in an explosion equivalent to the power of 1,000 atomic bombs. Why this small volcanic island in the Indonesian archipelago exploded with such ferocity has puzzled volcanologists for almost 100 years. In order to answer that question, Mike Rampino is on his way to Krakatoa, to the only part of the volcano that remains today, the island of Krakatoa. Rampino first visited Krakatoa in 1979 to pick over the remains of the eruption in search of vital evidence. He's now returning with local guide Samsul to confirm his latest theory.
The first time I was here with a group of scientists, we were looking at the pyroclastic deposits, the pumice deposits of the 1883 eruption, specifically to try and figure out what the triggering mechanism was for the enormous explosion that took place in August of 1883.
The initial theory to explain the extreme violence of Krakatoa's eruptions was that seawater seeped inside the volcano and mixed with the magma to create the huge explosions. This theory did not stand up to scrutiny.
We were testing the idea that seawater got into the volcanic vent, and that's what caused the explosion. What we found was that usually those kinds of eruptions have very, very fine-grained pumices. The pumices are fragmented by the reaction with the water. And here at Krakatoa, I've seen that the pumices are rather large. And so the lack of fine-grained material suggests that it wasn't seawater getting into the vent that triggered the eruption.
If seawater didn't trigger these huge explosions, what did? Hidden in Krakatoa's dense jungle are thick layers of pumice, ejected from the volcano in 1883. This volcanic rock is a permanent record of what happened deep beneath Krakatoa, and explains why it erupted with such exceptional violence.
Here we could find huge charcoal and also farmish everywhere. Yeah, here. This one. And then, oh, this is really big farmish.
Pumices.
Wow.
On the island, and the charcoal here, trees that were killed by the ash.
Yeah.
So beautiful sequence of pumices, finer grain, another pumice layer, but small pumices, and then the pyroclastic flow deposits going all the way to the top of the outcrop.
Like this?
Yes, yes,
Oh my God.
yes. The whole eruption sequence, you can see it here.
Molten rock lying inside Krakatoa's magma chamber for 200 years of dormancy was light in color and cool in temperature. After the initial eruption in May, the magma chamber was part emptied, and that void was filled from below by dark-colored magma that was extremely hot in temperature. It was a lethal cocktail. As the two mixed together, the intense heat of the dark magma created huge amounts of gas that expanded, eventually creating enough pressure to cause the volcano to erupt with terrifying force.
So this is the mixed pumice. It's got the light material and the dark material. Two different kinds of magma that triggered the 1883 eruption. This light-colored magma was sitting there for a long time in the magma chamber, and then this dark-colored stuff came in from the bottom, heated it up, and caused it to overturn, and for the gas to begin to come out of the magma, and the pressure built up, and that's what caused the volcanic eruption. Yes, yes.
This mixing of two magmas beneath Krakatoa was the direct cause of the massive explosions. But when combined with the volcano's unique position in the Sunda Strait, these explosions generated a series of giant tsunami. Some would be the largest waves ever witnessed. At 6:44, on the morning of the 27th of August, 1883, the second massive eruption occurred on Krakatoa. Pyroclastic flows of dense material cascaded down the flanks of the volcano, and immense submarine slides generated giant shock waves in the surrounding ocean. In the Sunda Strait, the shock waves were witnessed as huge crests of water.
God. Turn her into the wave now! As fast as you can! Rush yourself down!
When these first waves reached the coastline of Java, they slowed and reared up to enormous height, revealing the full horror of a tsunami. Today, all that's left of the Fourth Point Lighthouse are the remains of its foundations, a 6-foot-thick brick buttress. Despite its obvious strengths, the structure was unable to survive the enormous force of the tsunami.
The lighthouse seemed as if it was going to survive, but then it was hit by a block of coral estimated to weigh something like 600 tons, which had been scraped up from the seabed and which had crashed into the base of the lighthouse. And it looked as if it separated the lighthouse from its base, and the whole thing toppled over and was then broken up and carried off in the water.
2 years after the destruction of the Fourth Point Lighthouse, a new one was built just yards from the original.
The new Fourth Point Lighthouse, it's 40 meters high, which is just about the height of the largest wave. And looking down from here, it's almost unbelievable that you could get a wave that high. It would have completely trashed the whole region. I mean, a wave of 40 meters, and remember, this isn't just like a single wave that crashes onto a beach. Tsunami have very long wavelengths, so the waves can be hundreds of meters or several kilometers long, so they come in as a wall of water, and that wall just keeps coming, and it would have just wiped out everything entirely.
A total of 19,600 Javanese died on this stretch of coastline alone. These black and white photographs of the destruction, taken over 120 years ago, are sadly all too familiar today.
The 2004 tsunami was more destructive in the sense that it killed more people over a large area, and that is because such a big area of seabed was jolted upwards, and that sent these waves out. The waves generated by the Krakatoa eruption were much, much bigger, but they lost energy very rapidly, so they didn't travel any great distances.
The Fourth Point tsunami stripped the sand from the beaches and destroyed everything in its path. It seemed like the end of the world, but worse was yet to come.
The morning of the 27th must have been absolutely appalling, particularly after these gigantic explosions had started and after the first great waves had destroyed many of the communities along the coast of Java and southern Sumatra. So many people had already died, others were terrified. And I think people by then must have begun to wonder, is this the end of the world? Is this just affecting us here, or is everybody experiencing this?
At 2 minutes past 10, on the morning of the 27th of August 1883, Krakatoa exploded once more, this time with such extreme intensity that it was heard over 1/12 of the Earth's surface. The sound of the detonation was carried 2,000 miles south to Perth, Australia, and 3,000 miles west to Rodriguez Island in the Indian Ocean. It remains the longest distance traveled by any airborne sound in recorded history.
This was the climax of the whole eruptive sequence, one of the loudest noises, if not the loudest noise ever heard by modern humans.
When Willem Bering, the controller of Ketimbang, witnessed this huge eruption, he realized that the explosion would produce a tsunami of enormous size. The tsunami generated by Krakatoa would travel across the Sunda Strait at approximately 60 miles per hour, taking just 20 minutes to travel the 23 miles to Ketimbang.
We have to get to higher ground.
Fortunately for the Bearings, Ketimbang was situated at the foot of Mount Rajabasa. The Bearings escaped the clutches of the tsunami by climbing the slopes of Mount Rajabasa to 400 feet above sea level. By mid-morning on the 27th of August, 8,038 people had died around Ketimbang. Leaving death and destruction in its wake, the tsunami funneled up the Lampong Bay, continuing to slow in speed and gather in height.
Tsunami are all incredibly affected by topography, and they will get funneled by bays, by estuaries, by harbours, etc. And that happened here in Lampong Bay. The wave that devastated the entire low-lying region around the bay here. The fishing communities on Sumatra would have had no chance at all. The wave that came up this bay was 24 metres high, so you're talking maybe 80 or 90 feet high. This would have been a wall of water which just continued to come inland for several minutes. There would have been no chance to survive unless you were close to high ground and could actually make a run for it, because the waves would be travelling as fast as a sprinter could run, and most people wouldn't have a chance of outrunning that.
At the head of the Lampong Bay, lying directly in the path of the tsunami, was Telok Betong, the largest port in southern Sumatra. The entire town was washed away, killing a further 2,263 people.
This is the mouth of the river Koripan, which is at the head of Lampong Bay. And it's an excellent example of what Telok Betong would have looked like after the tsunami had funneled up the bay and then gone back out again. A scene of complete devastation, really. Mud covering everything, trees sheared off so that all you see are the stumps sticking up, and no sign at all of human habitation.
In the harbour at Telok Betong was the Dutch government steamship, the Baru. Its mooring buoy now lies as a forgotten monument to the dead. This is the only memorial for the Indonesian victims of Krakatoa. With similar power to the 2004 tsunami, the wave generated by Krakatoa picked up the steamship Baru and her crew of 28 and carried them inland. Their final resting place can be found almost 2 miles up the river Koripan.
The Beru was already suffering because the seas were getting very agitated, and then a big tsunami tore the ship from its mooring buoy and dumped it up this river here. This is where it all ended for the Beru and 28 dead crewmen. 1.8 miles up the Koropan River, about 30 feet above sea level. When the boat was found, which was about a month after the eruption, it was actually in very good condition. It was stretched across the river here. It was full of ash and mud, but its engines were in working order. And if it could have been got back to the sea, it could have actually been seaworthy again. But its real fate was much more ignominious than that. It just sat here rusting away for many decades, virtually disappearing after 50 years or so. Its huge boiler remained behind until that was washed down in a flash flood in 1979 and finally cut up for scrap.
At 10:45 on the morning of the 27th of August, 1883, the fourth and final eruption tore Krakatoa apart. When the ash and smoke cleared, the shell of the volcano had collapsed beneath the surface of the water into the empty magma chamber. All that was left was a remnant of the volcano, known as Krakatoa, and the existing islands of Valaten and Lang. One of the last casualties of Krakatoa was the Bering's child. Burnt, choked by ash and poisonous gas, the baby eventually succumbed to the trauma.
Madam.
So cold.
No, yeah.
Reports following the eruption reveal that the lighthouse keeper miraculously survived the tsunami. His wife and child did not. Despite his personal tragedy, records show that Temang stood by his post, performing his duty as keeper, warning passing ships in the Sunda Strait. Captain Lindemann and the crew of the Governor-General Ludon also survived the ordeal. Within hours of the final eruption, the dramatic news was being transmitted around the world. The names and obituaries of the 37 Europeans who died were widely published, but the names of the thousands of Indonesian victims were never recorded, and their personal details have been lost in time. In total, 36,417 people died, and 165 towns and villages were destroyed. It remains to this day the largest known death toll from any volcanic eruption.
Most of those deaths resulted from water, from the oceans, from the tsunami, not from the direct effects of hot rock. And that's something that many people don't appreciate about volcanic eruptions, even today, that the big killers include tsunami and include things like volcanic mud flows. And in fact, a number of the great disasters, volcanic disasters, have been caused by these relatively indirect effects.
But it wasn't just Indonesia that was changed by Krakatoa. 11 cubic miles of rock and ash had been blasted into the atmosphere. And for many years after 1883, the effects of the eruption would be felt around the world.
If you add up all the material that was erupted by Krakatoa and brought it to Manhattan, you could cover the island of Manhattan to a depth of about 200 feet. That's the volume of material ejected during the massive phase of the Krakatoa eruption in 1883.
No atomic bomb blast can rival the sound that the final eruption made. The shock waves from the explosion reverberated around the globe 7 times and were still detectable 5 days later.
Very few people appreciate how cataclysmic volcanic eruptions can be. And in fact, 500 million people live within the danger zones around active volcanoes today. That's more than 1 in 12 of the Earth's population. But the thing is, volcanoes aren't always going to sit there looking pretty. Every now and again they generate these cataclysmic eruptions. That's something that Krakatoa taught us, and I think people only then began to realize, certainly scientists, that a single volcanic eruption could be so powerful as to affect everyone on the planet.
Krakatoa erupted in a Dutch colony, but it was left to British scientists to document and analyze its effect around the world. Dr. Eleanor Highwood is a meteorologist at Reading University. She's visiting the Royal Society in London. The Society was established in 1660 to promote the study of natural phenomena, and in January 1884, it set up a Krakatoa committee to investigate the effects of the eruption on a global scale. Dr. Highwood studies changes in climate and atmospheric conditions after large volcanic eruptions, and the Royal Society contains the most comprehensive collection of material devoted to Krakatoa.
Are these for me? Yes, they are. These are the papers relating to the Krakatoa Committee, and that's the committee minutes.
Okay. Thank you.
The Krakatoa Committee collated in meticulous detail documentation from all over the world. They collected newspaper cuttings and ship's logs, commissioned scientific reports, and even invited the public to write in with eyewitness accounts of the effects of Krakatoa. The result was the most comprehensive report about a volcanic eruption of its time.
So this report starts right from the start of the volcanic eruption, talking about the geology, and then it covers everything. It goes through the sea waves. There's time scales for the atmospheric waves passing around the globe 7 times, and they're recorded everywhere from Australia right the way through to Oxford. Really a global phenomenon. And then an awful lot on optical phenomena, so twilight effects, sunsets, sunrises. So August the 29th, from Japan, the sun was blood red with jets like smoke passing across its face. A month later or so, Hazelmere in Surrey, light pink cirrus stripes at sunset. Buenos Aires, the last days of September, the glows began. They lasted 1 hour 30 minutes. The sun and moon were occasionally coloured. And there's evidence here that this continued for 4 or 5 years. This was really the first evidence that started to give meteorologists a good idea of how matter is transported through the atmosphere.
These changes in the night sky, within days of the eruption, confirmed the existence of high-speed, high-altitude winds that transported volcanic particles through the atmosphere. Today, these winds are known as jet streams, and their discovery has played a pivotal role in our understanding of the weather. The eruption of Krakatoa propelled 11 cubic miles of ash and dust into the air. The heavier material fell back to Earth, but the tiniest particles and sulfur dioxide gas continued to rise into the upper atmosphere. Within days, carried by jet streams, this aerosol of tiny droplets of sulfuric acid veiled 70% of the world and reflected solar radiation back to space. The result was an overall cooling of the Earth's temperature by 0.5 degrees Celsius. But this process had another impact on the globe. It turned the skies blood red. Housed in the archive of London's Science Museum is perhaps the most vibrant example of how Krakatoa affected weather systems on the other side of the world. Curator Wendy Sheridan is showing Dr. Highwood the work of Victorian painter William Ascroft. Between September 1883 and 1886, Ascroft sketched the changing skies from Chelsea, West London. The result is a series of extraordinary oil pastels.
This is the first panel of 72 of 533 sketches that the artist William Ascroft started sketching in 1883 when he noticed changes in the colours of sunsets, and he spent 4 years in virtually the same place sketching them, timing each sketch according to the changes in the colours.
So this sequence shows some particularly vivid colours, some very, very strong red and yellow coloration through the whole of the atmosphere. So these really vivid reds are a product of the fact that there was aerosol in the stratosphere that had been transported from the Krakatoa eruption, and light passing through that layer is scattered, but it's scattered differently depending on what colour it is.
Really?
And so we tend to see reds more strongly in sunsets and sunrises.
In an age of black and white photography, Ascroft's unique work acts as a time-lapse account of how Krakatoa, thousands of miles away, directly affected the British skyline. Over 120 years later, the story of Krakatoa is far from over. Although the eruption in 1883 almost completely destroyed the entire volcano, from its ashes, a new one is emerging. In the middle of the old caldera lies Anak Krakatau, the child of Krakatoa, and it's active and growing. Mike Rampino set foot on Anak 26 years ago. He's now returning there with Dr. Rudy Hadisantino from the Volcanological Survey of Indonesia. Rudy accompanied him on his first trip.
This must grow so fast. This
very fast growth, yeah, because there was almost no forest here when we were here last time. So the lava flows on the other side of the island, this side of the island mostly jungle. But so this is the end of the forest, and there is Anak.
Like
twice as big as it was 25 years ago, when I was here with you.
Yeah, right.
In its short life, the volcano has injured 5 tourists and claimed the life of 1, hit by a lava bomb exploding out of the crater. There's now an official warning advising against venturing onto the island.
It's hard to climb. Yeah, very steep.
Anak Krakatoa first revealed itself in December 1927, when it erupted violently just beneath the surface of the water. Since then, it has been erupting with increasing intensity and growing rapidly at a rate of 15 feet every year. Today, Anak is over 2,600 feet high, almost the same height Krakatoa was in 1883. It covers 1¼ square miles, and between 1992 and 2000, ejected over 50 million tons of material. It appears that Krakatoa is preparing itself for another huge eruption.
So almost at the main crater?
Yeah.
It's here. Oh,
Ah.
wow.
Wow.
My
Big
goodness,
gas
look at the size
on
of
the
this.
crater. What do you think the diameter?
It looks about 200 meters across, 600
Yeah.
feet across.
Yeah, I think so.
Yeah.
Yeah.
And the fumaroles
Yeah.
here. I'm choking though from the sulfur dioxide. We're standing here on an active volcano, Anak Krakatoa. The old peak of Krakatoa is behind us, and the old craters, the eruption centers for the 1883 eruption, were on the same line. So that's why volcanologists now think that there was a fault line, a fissure that ran along in a straight line here, along which all of these volcanic centers were erupting. The sulfur in them.
Anak Krakatoa is being carefully monitored by the Volcanological Survey of Indonesia, and particular attention is being paid to the viscosity of the magma.
Yeah. What's the temperature?
110.
110 Celsius. And then this is coated. In the future, we would expect that Anak Krakatoa would build a larger and larger volcano here, but eventually things going on inside the Earth will cause changes in the type of magma that's coming up, and the more viscous it is, the more chance of congealed magma sealing or blocking the throat of the volcano, the more chance of an explosive eruption.
Anak Krakatoa will continue to grow in size, and it's a geological inevitability that sooner or later processes deep beneath the volcano will cause Krakatoa to erupt once more with paroxysmal force. As we know from the tragic events of the tsunami of 2004, history repeats itself. And for the people of Indonesia living in this geologically unstable region, the unpredictability of nature is all too real.
The tragedy of Krakatoa was it was located in the middle of the Sunda Straits, surrounded by water and surrounded by coastlines that were fairly densely populated, very low-lying coastlines, unprotected in any way from these kinds of waves.
The work of Sherman, van der Stok, and the Royal Society was an important step in advancing modern science's understanding of how these geological processes work. But the challenge for the future is not just to understand these forces, but to predict them. The hard lessons learned are that the destructive power of nature should never be underestimated. Krakatoa and the tsunami of 2004 remind us that we live on an active planet where the Earth's crust is constantly destroyed and regenerated. These immense geological forces going on beneath us reveal themselves in unforeseen ways and with terrible consequences.